Here, which produces more severe burns, boiling water or steam? Now here we have boiling water, which is at 100 degrees Celsius, and the steam too is at 100 degrees Celsius. The temperature is the same for both, but who causes more severe burns? To understand this, let us just go over what we already have studied. Here are molecules of water, liquid water, and these molecules of liquid water, they take up heat, which is, we've learned, they take up heat which is called the latent heat of fusion, of vaporization, and they change into steam. So molecules of water take up the heat, they take up heat and they vaporize and form steam. Now the molecules of steam have got much more heat in them. So if I here were to draw the molecule of steam, these are molecules of steam, and here are molecules of liquid water. You will find this liquid water have got less heat, but the molecules of steam have got much more heat. So who releases more heat? If you were to put your hand, which you should not be doing, of course, if you were to put your hand in steam, the amount of heat released in steam will be more than that released by hot water. So here I have, see, molecules of water, and I have here molecules of steam. They come in touch with this surface. Where would more heat be released? You'll definitely agree that in the case of water, you will have less heat, but in the case of steam, there will be more heat released. So who will cause more burns? It is definitely, we see that steam causes more burns. And why does it cause more burns, more severe burns? Because the molecules have more kinetic energy. Hence, they release more heat. They release much more heat. They have more kinetic energy in the form of latent heat. So they release much more heat and it causes more burns. Here we'll see who's a better coolant, ice or water. So when we compare ice and water, we see that in ice, the molecules have got less heat. There's hardly any heat. They have very weak or strong forces of attraction. Very strong forces of attraction between the molecules, and there is very less heat. In water, the forces of attraction is less. In ice, it is more. And the water molecules have got a large amount of heat with them. They've got more heat. The water has got more heat because to change ice into water, that is melting, to change this ice into water, that is melting, heat is required. So who will be a better coolant? Water already has so much more heat, so it cannot absorb as much heat more because it is already, the molecules already have a lot of heat, while the molecules of ice have got less heat. Since the water molecules have got more heat, they will not cool the substance as much. Now the ice molecules have got less heat, so they can absorb more heat. So ice will be a better coolant than water, although ice is at 0 degrees and this water also is at 0 degrees. Both are at 0 degrees, but because ice has got less heat, it cools better. And water at 0 degrees is not such a good coolant.